So I already made a video about the NPM worm malware that was going around a few weeks ago. Well, version 2 just happened in the last couple of days. And I didn't want to make like another NPM worm video, even though it like happened again, because I already covered it a lot. But then I saw a video by the author of Trufflehog, which is a tool that the hackers are using in this attack to find secrets. The tool itself is not malicious. It just happens to be a tool that they're using. But Dylan, the author of Trufflehog, he's a friend, and he made a really good point that made me think, nope, I got to talk about this. So let's listen to Dylan really quick.
Realistically, the worm could have been a lot worse if it was leveraging all those other key types for its propagation instead of just limiting itself to NPM and GitHub for its propagation.
All right, so the point that Dylan makes is this could have been a lot worse. And I now, after reading his research and reading about this whole attack, I think it's gonna get a lot worse. We still don't know who is behind this attack, phase 1 a few weeks ago or phase 2 recently. But what we do know is that they've stolen a lot more secrets than they've actually made use of. So for that, let's talk about how this attack, this phase of the attack actually worked. So Wiz put out this great graphic that I think illustrates it fantastic for our purposes right now. So if you didn't watch my last video, or if you're unfamiliar about how this whole NPM worm thing is even working to begin with, the malware author put their malware in NPM in a package that developers would then include as part of their code. NPM is the largest repo of open source JavaScript code, and people include all sorts of stuff as part of their development process, even things that they could write themselves. They just choose not to. They can include a package that'll do it for them. Well, in this case, the attacker is just leveraging that whole ecosystem, publishing their malware there, which happens all the time. There are companies out there that just scan NPM for malware. But how this was different was that malware, once it got pulled onto the developer's machine, would scan that developer's machine for secrets, including API tokens, back to NPM and to GitHub. They would then use the NPM token that they found as part of the malware infection to republish themselves into whatever package that NPM token had permission to publish into. So as this shows, they found 500 different packages that they were able to infect. They put the whole Shai-Hulud runner into those packages, would scan for secrets, and then if those secrets included the NPM key, they would run this whole pre-install script that would self-replicate itself back into NPM. Hence, this whole thing is a worm. But NPM tokens were not the only secrets that A, they were looking for, B, they definitely found. So they did some neat tricks with like GitHub workflows in CI/CD pipelines to do some data exfiltration. So instead of like installing some additional malware tools or anything like that, they just used what was there, kind of like a live off the land type thing. They used the keys that they found to then publish these malicious workflows to GitHub CI and exfiltrate whatever other secrets they found. Trufflehog is an open source tool you could use to find secrets in your code. And it doesn't just look for these kinds of secrets. It'll find all sorts of other stuff like AWS, Azure, GCP, keys, whatever it is. So to Dylan's point of the video that we just played, so far, all this worm has done is replicate. All they've really made use of is the NPM and GitHub tokens. And I want to get into why I think this is going to get a lot worse, and then also like how you can spot if you were infected by this and all this. But the sponsor of today's video is actually perfectly aligned with the topic because they just put out something free that you could use and download to help protect against this exact type of thing in secret theft from malware like this. So a quick word from them. We'll be back right to this. I love observability. I want to know what's going on. Otherwise, I cannot respond to it. I've talked about that a lot in my videos, and it was part of my job, part of my life at every role that I've ever had. And one of my favorite observability technologies is canaries. Can I put something in my data on my machine, in my cloud, on my servers that normal humans will not touch, but attackers will touch? And guess what? I'm watching. I'm waiting for them to touch it because then I'll get an alert. Well, that's why I'm super excited to show you the sponsor of today's video, Tracebit, who just launched, this is super exciting, a free community edition. So you better believe that I am installing it right now live for you. You can see how easy it is. I installed their CLI interface. So all I have to do now is run this deploy all command, and I'll get canaries on my machine that Tracebit will be monitoring for if an attacker actually gets malware on my machine, like say the malware that's going all over NPM right now, and they start looking for secrets, they're going to gonna trip over my canaries. So I'm through setup. That took me minutes. I've deployed a bunch of canaries. I put canaries in my password manager. I put canaries in my email account, and I put secrets on my machine that are canaries. So here you go. You're watching me log in for the first time to Tracebit Community Edition. Super excited. So I've already triggered some alerts so that we could see them on my screen. They give you a command in the command line to test them out. So if we go to alerts, we could see I used a fake username and password that I've stored in my password manager that should never be used. And if they're used, they were stolen, and this canary went off. All right, so I've gone ahead and triggered a few more. So I pretended to steal my own SSH key, and I pretended to steal some AWS secrets that, again, should never be used. These are completely fake. You actually see in the Community Edition, they have this cool level up method. You can go from different tiers as you gain more trust within the system and you're active. They'll even give you access to more features for free, including stealthier features, because maybe the attackers get wise to some of their community features. So thanks Tracebit for supporting the channel. Obviously, their Enterprise Edition has tons of other features. They've got some cool companies that I know have solid security teams like Riot Games that are checking them out right now. And if I were you, I would be throwing these things everywhere. This is like hot off the press. The Community Edition just came out. They partnered with me to help amplify this message of their Community Edition. Please go check it out. A, why not? Super cool, easy, free, takes you a few minutes. B, best way to support this channel by checking out the sponsors. Let's get back to the video. All right, thanks Tracebit. Perfect timing on sponsoring the channel because this is so aligned and it's free. I mean, we all love free. So how was this version 2 of Shai-Hulud worse than version 1, and why do I think it's going to get worse before it gets better? So A, just the size of this attack was so much worse. We had 25,000 malicious repos across 500 GitHub users. Unit 42 put out some really good threat research here that made a few other good points about differences between version 1 and version 2. And in this time, the campaign was so much more aggressive that basically if it couldn't find the kinds of secrets that it was looking for, it would just scorch earth. Kind of didn't mention this on that whiz graphic, but we had this conditional wiper here. Basically, if all else failed, they just tried to nuke the developer's home directory. And then this like GitHub repository data exfiltration technique was also new. So we're seeing the attack evolve. We don't know who's behind it yet, and they're collecting way more secrets than they're using. Socket is a team that checks NPM for malware and PyPy for malware. We've covered them on the channel before. I even had the founder for us on to chat through the last version of the worm. If you guys like that interview and you want him to come back and talk about version 2, let me know below, and I'll give him a shout. But they go through a bit of a technical analysis, and they link a postmortem from one of the victims that I want to go through, because it's always really good to go through a transparency like that of like a victim to see what they saw as it all went down. So this attack, it detects what OS and architecture it on. This other new part was that it locates a Bun runtime. I think Bun just got acquired by Anthropic too, so they've been all over the headlines lately. Wildly popular though, but it caches the Bun binary into the hidden cache directory. It spawns a detached Bun process running bun environment.js with post install background flag, and then it suppresses all like the standard out, standard error stuff, so it gets a little quieter. One of the cool things about an attack like this is that it's happening on GitHub, and GitHub is almost entirely public. So you can find some cool GitHub search queries that return a bunch of the compromised repos, and you can kind of see what's going on there. So their beacon phase that they were using here in this one was the Shai-Hulud, the second coming. They were doing like a GitHub search as part of their attack. If they found that beacon, they would read a stored file containing the GitHub access token, because if it was published, it had access to the access token. And the postmortem we're going to get to in a second, this was how they got in. And then it uses this recover token. So this makes the malware self-healing. If a victim deletes previous malicious repositories, the attacker can reseed victims through GitHub search. The beacon phrase also serves as a campaign signature for tracking infected repos. So here's a bit of the payload and how it detects some of the hostname and architecture type stuff, and then how it detects the CI/CD type stuff in GitHub Actions. We saw this on the whiz diagram. It does a whole bunch of privilege escalation, right? So it's going to first try to do a passwordless sudo. If that fails, it's going to do this docker run command and grant itself passwordless root access to the GitHub action runners. This is so nasty to do this in CI. I've never seen anything like this. So now it's got privileged access in GitHub Actions in the CI pipeline. It can then do DNS configurations, restart, flush IP tables and restart the whole thing. And then this gives it network level control within the CI environment, which is insane. Continuous integration is wildly privileged. At that point, you basically own the entire build process and can inject at a bunch of different steps in the process. The whole point of CI is to remove humans from the whole build process and deploy with a whole bunch of steps to make sure that everything gets built properly, tests are passing, security scans happen, security updates happen, package updates happen, whatever it is. So if you own that whole process, guess what you can do? So then, as I said, it runs Trufflehog as part of his attack. Dylan from the the clip that I showed at the front, wrote Trufflehog. So he, of course, doesn't love how everyone is kind of framing it as this new hacker tool, even though it's just a secret scanner. Not to minimize the usefulness of Trufflehog. I was a very happy user of Trufflehog many times in my life. But because it's a secret scanner, it's useful in this attack. So they download Truffle from their public repository, and then they run it and try to find new secrets. Like we said, they try to find AWS, Google Cloud, and at Microsoft Azure secrets. Those are all super useful for an attack like this. And then the exfiltration is super unique. So it creates the GitHub repository in the victim's account using the stolen GitHub token, randomly generates the repo name. It does 3 levels of base64 encoding on it, which doesn't sound that crazy, but really all it does is to break, GitHub is scanning its own users' repos for secrets to try to prevent you from accidentally publishing secrets. People do it all the time. They push their API keys publicly without realizing it. Well, if it's triple base64 encoded, it's not going to get found. And then, like we said, it propagates itself. I'll include a link to the socket blog below because it also goes through all of the repos that are known to have currently been infected. One of which, at the top, like I said, they talk about a postmortem, was PostHog. PostHog is a wildly popular open source tool, so they made a really good patient zero victim for this. So they say an attacker briefly opened a pull request that modified a script executed via pull request target, exfiltrated a bot's personal attack token from CI, and then use that to access and steal additional GitHub secrets from PostHog. This was not part of the worm. PostHog wasn't a victim of the worm. They were targeted as a patient zero. So I want to go to PostHog's postmortem really quick. I mean, first of all, this website is just super cool. So they get right into the details of what should you do. I guess we can cover that at this point in the video too. But they suggest you look for the malicious files in your home folder. If they weren't nuked, like we saw that part of the attack could nuke your home folder and erase some of their tracks. But here's some stuff that you can look for that the attack definitely creates a file called truffle secrets, an environment JSON, cloud JSON, a bun environment JavaScript file. You can check your npm logs for suspicious entries, including the name or these pre-install scripts. And once you're sure you're not on any infected dependencies, you got to make sure that you get rid of any cached dependencies, because these things don't even need to be in use for the malware to be active on your machine. They also suggest, and I think just best practice generally agrees here, to set a minimum release age before you're automatically downloading packages out of things like npm. They say something like 3 days. But here's the part that I wanted to go through. How did it happen to PostHog? Because they weren't a victim of the worm. Like we said, they're patient zero, or at least one of the patient zero. And it all came down to a GitHub personal access token of one of their bots. A now deleted user opened a pull request against PostHog, which included this commit. That's it. That's the whole commit. So in their assign reviewers file, they created a variable that executed a curl command that printed some environmental variables to this webhook site and then immediately exited. The way that they had their CI set up, it said this PR changed the code of a script executed by the workflow we were running against external contributions, meaning someone from the PostHog team didn't open this PR. This is a PR just randomly from the internet on an open source project. So it was modifying it to send the secrets available during that script's execution, those environment variables that we just saw in that commit, to a webhook controlled by the attacker. These secrets included the GitHub personal access token of one of our bots, which had broad repo write permissions across the organization. The PR itself was deleted along with the fork that it came from when the user was deleted, but the commit was not. Yeah, GitHub is pretty forever. Even when you start deleting stuff, you can find things in GitHub history. PR was open, the workflow run, and the PR closed within the space of 1 minute. Then the attacker used these credentials to delete a workflow run. We believe that this was a test to see if the stolen credentials were valid. Then a few minutes later, the attacker used the stolen credentials again to create another commit masquerading by chance as the report's author. We believe this was randomly chosen branch on which the author happened to be the last legitimate contributor. This is super, super interesting because this isn't the worm. This is the actual attacker poking around, finding, kind of striking gold with this personal access token. So sorry I'm reading this directly. It's just fascinating, and I really want to go through it all and get all the detail. The commit was pushed directly as a detached commit, not as part of the pull request or similar. The attacker modified an arbitrary lint PR workflow directly to exfiltrate all of our GitHub secrets, unlike the previous PR attack, which could only modify the script called from the workflow, and as such could only exfiltrate the bot PAT. This commit had full write access on our repository, given the ultra permissive PAT, which meant they could run arbitrary code on the scope of our GitHub Actions runners. With that done, the attacker was then able to run their modified workflow, and they did so literally a few minutes later, 2 minutes later. Principle associated with these workflow actions, posthog bot, our GitHub bot user whose pat was stolen in the initial PR. We were only able to identify the specific commit as the pivot after the fact using GitHub audit logs due to the attacker deleting the workflow run following its completion. So they were pretty successful in covering their tracks up. Obviously, there's some logging there. At this point, the attacker had our NPM publishing token, and 12 hours later, the following morning, they published the malicious packages to NPM, starting the whole worm. As noted, posthog was not the only vendor used as an initial vector for the broader attack. We expect other vendors will be able to identify similar attack patterns as our own audit logs. This is why I'm honing in on this postmortem, not necessarily all the victims of the worm. This was actual attacker behavior. They go into the architecture of why this happened. This is all super common behavior. Posthog is not alone in setting up a lot of these automations via GitHub Actions in CI to their code. So they basically had this on pull request thing, which would set off a whole bunch of actions that the attacker was able to, maliciously use, take advantage of. Basically, this assign reviewers JS file that they had to assign a reviewer to public contributions had a vulnerability that let them run arbitrary code, which is what that curl command was. And it was running in the context of a trusted CI run, which is why it had access to the environment variables, such as the PAT. So they talk about what they're doing to prevent this from happening again. These are all good pieces of advice if you run a big open source project. They've significantly tightened the package release workflows, moving it to the trusted publisher model. They've increased scrutiny on any PR in a workflow file gets requiring specific reviews from someone on the security team. And they switched to PNPM 10, and they disable the pre-install and post-install scripts, which were used in this attacks. And they talk about that minimum release age on new packages to 3 days. And super important, they reworked their GitHub secrets management to make the response to incidents this faster and more robust. How many times have I been part of a major incident that all of a sudden the long tail of work for that incident was, we got to find every freaking secret that they had access to during this. You had no easy way to figure it out. That's when I've actually used Trufflehog, or we've even kind of Frankenstein Trufflehog into finding specific secrets that we needed that it couldn't find out of the box. And, it was days and days worth of work to find all the secrets and rotate them all after an attack. Okay, but back to that Dylan video that we talked about in the first couple seconds of this video. I want to play the whole video. It's 2 minutes long. Go ahead and skip forward 2 minutes if you don't want to watch Dylan talk. I'm going to evaluate what he says after it, but I want to play the whole video.
Was way less powerful than it could have been. Hi, my name's Dylan, and I'm the original author of Trufflehog, a tool that the Shy-Huddle worm used to steal everybody's secrets. The latest Shy-Huddle worm infected about 700 NPM packages and probably at least 27,000 individual machines that installed those packages. When somebody installed one of those packages, it would look for more NPM tokens so that it could infect more packages, and would also look for GitHub keys. And if it found a GitHub key, then it would infect all the GitHub repositories that key had access to steal all the secrets out of GitHub Actions. Both of those actions were recursive, which makes it a worm. You steal secrets to find secrets to find secrets to find secrets. But I say it's underpowered because it used Trufflehog to find all kinds of secrets that it wasn't actually using for replication. Like if it found a Slack API key somewhere, or a Postman API key somewhere, or even a secret manager key somewhere, it didn't look inside those places for more secrets. It only used NPM secrets and GitHub secrets to look for more secrets, even though it stole all the other types. It just wasn't using them for replication. So realistically, the worm could have been a lot worse if it was leveraging all those other key types for its propagation instead of just limiting itself to NPM and GitHub for its propagation. I first talked about API key worms back in 2021 in the context of S3 buckets, which have keys in them, which give access to buckets, which have keys in them, which have access to buckets, and so on and so forth. But realistically, any API key to any provider gives you access to more data typically, which has a chance of having more secrets, which has a chance of giving you more access to more data, and so on and so forth. I really do think we are overdue for a much larger API key worm that instead of only leveraging two platforms to steal secrets, it could leverage dozens of different providers and take advantage of all those keys that it's finding along the way. And I do not think we are prepared for that. There are just so many API keys out there right now. The state of the industry is wildly underprepared for a worm that just leveraged two.
Okay, so I think that this is a super important point to dig into. Dylan has the street cred for it. Literally, you can pull up the blog on the Truffle Security blog from 2021 that he's talking about, where he called it. He called the shot. He said, hey, we're going to see a worm that's going to be made of API keys. Here we are. And to his point, they were only using NPM and GitHub to replicate. And this whole like GitHub replication thing was actually an iteration from the first time that they did this a few weeks ago, which was kind of like a clever use of the GitHub actions to replicate. I'll leave a link to this research from 2021 down below, but I mean, he basically is just talking about how many AWS secrets that they find with Truffle all the time. And it's not just AWS keys. Twitter, Slack, Firebase, Dropbox, all these kind of stuff, PayPal. So not only could all of these things be used to like steal information, because obviously if they're secrets, they could be used to steal information, but they could all be used as a worm to replicate, just like we're seeing with Shai-Hulud. So what he's talking about here is, yeah, we're going to worm around GitHub and NPM, but what would have stopped the worm from doing the same recursive thing via S3 buckets or via Dropbox? Oh, you found Slack? Great. Now I'm going to use that Slack token to, instead of just stealing information out of Slack, which of course it could do, it could replicate via Slack as well and steal more Slack tokens and so on and so forth. So this worm could turn into like a Hydra with many different heads of the worm. Instead of just NPM and GitHub heads, it could do all sorts of other stuff. The reason I'm like joining Dylan and predicting that this is going to get worse before it gets better is because even in this attack that we just saw, they stole more secrets. They just didn't use them to replicate. So what's to stop V3 of this worm from already getting a lot worse? Dylan has like a written version of that video that he just showed where he just kind of talks about it. You know, there was no reason that this worm needed to stop at just NPM and GitHub. This whole recursive thing could absolutely happen with a number of other different API keys. Dylan's proposed 3-step, plan on this. We have to clean up exposed keys everywhere, not just GitHub repos. We have to rotate keys every time they're exposed, and we have to build systems that assume that these keys will leak, because this could have been a lot worse. This whole aggressive fallback thing where they nuked devs' home drives, that's just like a flex and a cover up. You understand what's going on here, right? They're running commands on these machines. They could have done a whole lot more with this malware than just kind of replicate and steal secrets. This is code running on your machine as a developer just because of an NPM include that you had that might have been fine at, 2 hours ago, 10 minutes ago, and is now malware. So that's why the sponsor of today's video was such a well-timed thing. I was so excited when Tracebit said, hey, we're releasing a community edition of these canaries. I went through the install immediately. I was like, okay, I'm putting fake secrets on my machine. Tracebit's watching. If I am a developer, I am coding on my machine. I do use NPM every day. If all of a sudden I wind up with a malicious package, now they're going to trip over my canary secrets. Thanks, Tracebit. Go check out their free community edition down below. It's a really good way to support my channel. They see that you're coming from me. Tell them I sent you, that kind of thing. Really good. And please do all the subscribe things. I crossed 20K subscribers this week. Super exciting milestone, but it's just the start. I'm going to just keep yapping on here. Share this around with any developers, especially JavaScript or Python developers, because NPM and PyPy were the ones that were seeing a lot of this malware in. Appreciate the support. Follow for more cybersecurity news.